Hi! In this video we're going to create a custom model for Source 2 of an inflatable toy with the shape of a pink flamingo. This is a kind of prop that I did on my CS2 version of Pool Day, and we're going to make it react the same way, which means players can move it around, and if it breaks, it deflates and falls on the ground. At first, I'm looking for a reference to help me find a good shape. In this case, it's a picture of a pink flamingo inflatable toy that I find cute, so that should be enough, but feel free to use whatever fits your needs. We're going to start in Blender by doing the high poly version of our mesh. To do that, we're going to start by making a simple 3D model of our shape, using the reference on the side. So here, I'm using classic Blender modeling methods, but you're free to do it any way you want. The goal is mostly to have quads, and quads that are roughly all the same sizes. Once we're done, it's always a good idea to check that all the normals of the faces are correct, which means that by using the face orientation option in the viewport overlay, everything is blue. I'm going to apply the mirror modifier I used for this, and it's a good idea to save your work somewhere. In my case, I'm simply saving the blend file in the contents folder of my add-on. I'm going to rename the collection High Prep so that I can save all the progress I'm doing on the preparation for the high poly mesh in here. I am now going to save it, and on a new version I'll add a subdivision surface modifier with a power of 2. In my case, I want the base of the neck to be sharp, so I'm going to increase the crease value on these edges, but that depends on the geometry you're doing. And finally, I'll apply the modifier. If I take a closer look at my reference, I can see that there are some sewings between the plastic parts, and these are going to be important. So back in edit mode, I'm going to select all of these vertices, and in the Object Data Properties tab, I'm going to save them in a vertex group that I'm going to name Pinned Vertices. I'm going to save a new version of the mesh, and we will now start toying with some cloth simulation to get the real high poly version of our mesh. So back in object mode, reach the physics tab and click on the cloth box. In here, we have a lot of values we can tweak, so I will try to use only what's necessary for this tutorial, but you can try to tweak the values and check how it goes. First, I'm going to change the vertex mass to 0 so that gravity doesn't affect our simulation at all. Below, I'll check the pressure box so that we can simulate our object as if it had air pressure inside of it. Let's start with a value of 5 and press the play button in the timeline tool. From there, we can tweak the values in real time and see how it affects our simulation. So for instance, if I increase the air pressure, you can see the effect it has on the simulation. But let's keep 5 for now. Below that, in the shape category, we can use the vertex group we defined earlier as a pin group. It means that these vertices, no matter what happens, will always keep their initial position. And finally, we have the shrinking factor. If you put a value in here, the object is going to shrink, which is cool, but it's not exactly what we want to do. We want the opposite, so we're going to use a negative value of minus 0.1. I will increase the pressure to 40, make the shading smooth, and that's going to be it for the simulation configuration. It's a little bit too simple though, as it doesn't have enough geometry to make finer creases in the simulation. So what I can do is add a subdivision modifier above the close modifier so that it uses a mesh with higher definition. And that's good enough result for me. I'll pause the simulation and add another modifier below to get smoother geometry for the high poly mesh. Now that we have our high poly mesh, I'm going to save it in a collection named baking. I'm going to run the simulation for a short moment to make sure that it's correct, and then I'll apply the first subdivision surface modifier and the close modifier to create a copy of the object afterward. One of the two is going to be the high poly mesh, and the other one is going to be the low poly mesh. So to begin, I will apply the modifier on the high poly mesh and remove it from the low poly mesh. If we look at the statistics of our low poly mesh, we can see that it still has too much geometry. In this case, around 50,000 triangles, and it would be better to aim at something like 3,000 to 4,000 triangles. So one way to deal with this is to use the decimate modifier with a ratio of 0.08, for example. This works as we get a result of 4,000 triangles, but the geometry is a bit stretched everywhere, which can result in problems later with the lighting or the baking. But it's fine, to be honest, that's what I did for the ones from Pool Day, and they look fine. What we can do instead is use at first the remesh modifier, which will rework the topology of the mesh for us, following a pattern with the voxel size that we set. In this case, 0.05 meters is close enough to the original geometry, so we can apply that and do a decimate modifier right after. With a ratio of 0.25 here, I get a result of roughly 3,300 triangles with non-stretched geometry, so perfect. So let's apply that and smooth the geometry of both mesh, and we're good. Let's now take care of the UV unwrap of the low poly mesh. Because this is a result of a decimate modifier, our geometry is not very appropriate to do some manual UV unwrap. So it's a bit messy, but using the Smart UV project in the UV unwrap menu will be good enough for this. I will use a high value for the angle limit, and I will increase the island margin value so that each island is separated from the rest. And starting from here, there are probably way better ways to do it, and I'm clearly not a UV expert, but I'm manually trying to rearrange everything to maximize the usage of the UV space. Okay, we can now start working on our material. So I'll start by creating a material for a low poly mesh that I will name after my object. Then let's switch to the shading tab. In here, with Shift A, we can go in the texture menu and create an image texture node. I'll create a new texture that I'll name Bakings because it's the one I will use for my bakings. And I will use a resolution of 2K and disable the alpha channel. Then we have to check something in the Preferences menu. So go there, go to the System tab, and at the top of it you should click on the option that works the best for your GPU. If you have an NVIDIA GPU without RTX support, like a GTX card for example, you should use CUDA. If you have an NVIDIA GPU with RTX support, like an RTX card, you should use Optics. If you have an AMD GPU, you should use HIP, and if you have an Intel Arc GPU, you should use OneAPI. But this information could become obsolete in the future, so maybe look for it online to be sure. In my case, I have a RTX GPU, so I'll use Optics and save the preferences. In the Render tab, we can now switch from EV to cycles and make sure the device used is GPU compute. We will now go in the Bake section we will start by baking the normal map. Check selected to active so that we can select precisely which object is baking over the other. In here, use the exclusion setting with a value like 0.1 meter as a starting point. We can increase the margin, and we are ready to bake the normal map. In the preview section on the left, make sure to select the texture named bakings to be able to see the result in there. In the outliner, I will first select the high poly mesh, hold Ctrl, and then select the low poly mesh. And finally, I make sure to select the image texture node, and I can click on Bake. This will take a few seconds to compute. Now that I have my normal map, I want to verify that it worked. So I'll plug the image texture node in the normal input of the principal shader node. With Shift A, I will look for the vector category to create a normal map node that I will place in the middle. And I'll switch the color space from sRGB to non-color. And so now, if I hide the high poly mesh and switch to material preview in the viewport shading, I can see that baking worked fine and the normal map is working. In the preview section on the left, I'll save the current image to be my normal map. I'm saving this in the content folder of my add-on, more specifically in the materials folder, and I'll name it buoy_flamingo_normal. We can now do the ambient occlusion mask, so I'll switch to the sRGB color space. I'll change the bake type to ambient occlusion. I'll make the high poly visible again, select it, then hold Ctrl and select the low poly and hit bake. To verify if this one worked as well, we will simply plug the image texture node in the base color input of the principal shader node. And we can save this mask as well, this time with its name ending with _AO. We will now make an attempt at doing a decent diffuse mask for our material. So brace yourself, this is going to be a bit rough, but it's fine, it's just a funny prop, no pressure. So for that I'll create a new texture that I'll call Diffuse, and it's still in 2K, still without an alpha channel, and I'll try to eyeball the background color to be the color of my pink flamingo. But of course I'm completely wrong and I have to give it a few more attempts before getting somewhere. And from this, I'm trying to use the texture paint tools of Blender to draw the beak, the eyes and the wings. But as you can see, it's really simple and you could probably do a way better job with a drawing tablet and with some art skills. When I'm done with it, I save it along with the other textures, this time with its name ending with _color. I will now create a custom collision model for my flamingo. So I'll create a new collection for it, and I'll start with the torus shape. And this time I'll do an even simpler geometry for the mesh, of course. And how I do it is that I split my mesh into several chunks of geometry, and I make sure they are all convex hull shapes. Okay, so that's good. We can now export our two meshes. I will start with the main mesh, which is the low poly version. So I select it in the outliner. I go to File, Export, and pick FBX. Once again, this is going to be placed in the content folder of our add-on, and more specifically in the models folder. I give it a name. I check the selected objects box so that only the selected object is exported in this FBX, and hit export. And I will do the same with the collision mesh, this time with its name ending with _col. Okay, we will now begin to see some result of all of this. So let's start the workshop tools and open the material editor. I'll create a new material, and for the shader I'm going to use the default CSGO environment shader. If you don't see it so easily, make sure to have the box Show Preferred Shaders ticked. I will start by saving the material. I'll place it in the same folder as the textures we exported earlier, and I name it buoy_flamingo. I can now configure the material so that it uses the color texture we painted earlier, and because we named our files in an organized matter for source 2, it automatically detects the normal and ambient occlusion textures as well. For the roughness, I'll click on the button to use a solid color instead of an image file, and I'll use an RGBA color of 50-50-50-0, which means it's quite a dark gray, so our material will be quite glossy overall, and that's something we want for a plastic object like this, I think. Of course, feel free to tweak these values yourself, or even make a proper roughness mask. I'll do it this way for the sake of simplicity for this tutorial. Okay, now let's import the models. So open the model doc editor. I'll double click on model to create a new model. For the archetype, we're going to start with a physics prop, and more specifically, we'll pick the entity prop physics multiplayer. With the star button, I'll pick the add meshes option and find the FBX of the main mesh. And by pressing the needs compiling button, I will first save the object in the folder where are stored the FBX files with the name buoy_flamingo. So here, because we named everything the same way, it automatically found the material we just created before. But if it's not the case, you can search for default material group and set your material in here. For the collision, we will search for physics hull file and select our collision mesh. The import mode is set to be a single hull by default. Let's switch it to hull per element and compile our model, and it's working at the right place and the right scale. As we can see here in the collision properties, the calculated mass is huge. Here it's 40 tons, which means it weighs just as much as 30 to 40 cars. So this is due to the default surface property, and something else we'll see in a moment. But we should pick instead the soccer ball surface property. This is super important because this is what makes the object kickable by the players, just like a soccer ball. And as we can see, the object now weighs 248 kilograms, which is still way too much, but it's better. I will now add the prop data entry. In the base prop text box, I can write plastic_break, but maybe it's going to be in red, so we'll fix that later, don't worry. I will give a health value to our object so that it breaks if it receives at least that amount of damage. And finally, we can look for an ambient occlusion entry. In this case, I'm going to use the capsule one. This will allow the object to display some real-time ambient occlusion on the environment close to it. So I will simply configure a sphere with the capsule shape and compile my model. By pressing the play button on the top left of the 3D view, I can do some tests to see how it goes. So if I click on the ground here, it's going to spawn the object. And as we can see, it's way too big. With the hand tool, I can move it around, so it's a success, but I'll have to do something about the scale. So here I'm going to load hammer, use the duck prop as a reference, so the one I already did for pool day, and scale my flamingo prop so that they have the same scale. I notice that I need to scale my object down to 0.2, so I will keep this value in mind. Back in Blender, I'm going to scale down my objects, so I select the low poly mesh, I make sure that the transform pivot point is the 3D cursor, I go back in object mode, and with the 3D cursor at the center of the grid, I press S to scale, 0.2 on the numpad, and enter to validate. I will do a Ctrl A to apply the scale, and I repeat the same process for the collision, and I can now re-export the two FBX files. Now let's go back to Model Doc. If we compile our model, it will immediately update the scale. But as you can see, the ambient occlusion we have set is obviously way too big, so it needs to be scaled down as well. So let's test this again within Model Doc, place a few of them, and it seems to be working nicely. So now I'll place a few flamingos in a test map, and as you can see, they work pretty well, and we can already play with their physics. So nice, cool. But if I shoot at it, nothing happens. So let's finish by making this truly systemic, and let's go back to Blender. Once again, I go back in Blender, I create a copy of my low poly mesh that I'll place in a new collection called Ragdoll. We will now attempt to sculpt it so that it looks like a deflated version of the mesh. And how I do this is I use the inflate brush, but in reverse by holding Ctrl. And I'm then going to deflate the model as much as I can everywhere. As you can see, sometimes the geometry is going to fold over itself, but we're going to take care of that right after. So this is enough. If I check the face orientations, I can easily spot where the geometry is folding over itself. To simply fix this, I use this smooth brush and do single mouse clicks here and there to fix this. At the end, we have a clean model with the same amount of triangles as our low poly mesh and using the same material, so that's convenient. We will now create an armature. This might sound weird as this is usually used to make animated models with skeletal mesh, but it's actually also what's used for the ragdolls of dead characters in games, for example. So we will create an armature by doing Shift A and pick Armature. I need to switch in edit mode, and as we can see, there is only one bone for now that we can trick by moving its two ends. So I'm trying to place the first bone like this, but I don't see it because it's hidden behind geometry. So in the Data tab and in the Viewport Display category, I can check in front so that it's always in front of the geometry. And I will now extrude the ends of the bones to try to model a skeleton of my mesh. One last step is to do the rigging, which means telling the skeleton what parts of the geometry has to move with each bones. Once again, this is something that is a profession in itself, and we will just use an automatic method to get some decent results. So in object mode, I select the mesh, I hold Shift and select the armature, and I press Ctrl P and select the option with automatic weight. And now, if I go in pose mode, I can select each bone and try to rotate them with R and see if the geometry follows. Of course, every time I cancel the rotation with right click, it's just to check if it reacts as expected. So everything is fine. I can select both objects at once and go to File, Export, FBX, name my object with _ragdoll at the end, make sure the selected object box is ticked, and in the armature category, make sure that the box Add Leaf Bones is not ticked. Let's get back to Model Doc Editor and we'll create a new model. So at first we will set the archetype to be joint physics prop and the entity to be prop ragdoll. With the Start button, we will import our Ragdoll FBX, compile the model and save it with _Ragdoll at the end of its name. If we take a closer look at our object, we can see white lines. This means that the skeleton has been imported correctly. We can now search for the option Create Ragdoll Parts. This will open a window where we can choose which bones we want to use, so we are basically going to check all the boxes and hit OK. This generated a lot of data. So at first we can see that it created a lot of collision spheres, each of them being attached to each bones. And then there are also several physics joints that are connecting the bones with each other. There's a lot of stuff you can configure in there, but what we will focus on is the placement and the size of the collision spheres. So you can select one collision sphere, you can press T for translate and move it around. You can press Tab to switch between global and local reference. So what I'm doing here is placing each sphere roughly at the center of each bone. I can then select them all and set a bigger size to start, and readjust for each of them their size and location along the armature. These spheres are the collisions of the ragdoll. They define how it's going to collide with the world and everything else, including the bullets if someone shoots at it. So ideally you want it to match your geometry as much as possible, but you'll have to make compromises. You can also use boxes instead of spheres if you want. It works better for certain cases, but I will keep things simple for now. I will press the play button once again and see how the ragdoll moves around and reacts to its environment. With the hand icon, I can grab it by its collision spheres and play with it. This is optional, but I can also use ambient occlusion capsules and attach them to each bone. So it takes a little bit of time, but I can add several of them and get convincing ambient occlusion lighting of the ragdoll with the environment around it once in-game. If your object has an armature that must have a closed loop, like this frog I did for example, you will have to add another joint at the opened loop, or simply use a weld joint like I did here and configure the two bones that needs to be linked. If you don't do that, well, it's funny, but maybe it's not exactly what you want. So, finally, let's go back to Model Doc and let's make our object actually breakable. So, if we look back in the prop data properties, you may remember we had this value in red. It's because some data is currently missing on CS2 tools. So, in a link in the video description, I will share an archive that you can unzip within your add-in content folder, and once it's done, you can restart the tools. If I load my object in Model Doc, I can now search for the base prop property and pick plastic.break. I will now finally add the last piece of this puzzle, which is the BreakPiece external item. This will allow my object to spawn another object when it breaks. This spawn object is a ragdoll, so I'll check that. It's on the collision group debris so that it doesn't collide with players. I can tweak the fade time that defines how long it will take before this spawn object fades away. And finally, I can set my ragdoll object to be the model to spawn. I compile it and test it right away. So I place a few flamingo toys on the ground, and in this menu I can choose a weapon to shoot with where I click. So if I shoot at the flamingo, oh yeah, they break and spawn the ragdoll. Success! I can also place a flamingo on top of any kind of geometry, and if I shoot it, the ragdoll will fall in a convincing way. So in Hammer on my map, I will place a prop physics multiplayer entity, and I will pick my flamingo model. And under the physics properties, I will increase the buoyancy scale to 10. This will ensure my object will float on top of water. So this should work, but I'll turn this into a prefab to be able to play a sound when it breaks. Hopefully I find a better way to do it in the future, like maybe play the sound event directly through Model Dock, but I haven't found any other way, so let's do this with a prefab. I will save it in my prefabs folder and open it separately. I'm making sure that the transforms are all at default values. I will give my flamingo a name, and I'll add a point sound event entity at the center of the grid. So I'm giving it the name Flamingo Sound Event. I use a custom sound event I made for this. And I set the source entity name to play the sound at the location of my flamingo. I end up by adding an output on the flamingo so that when it breaks, it tells the sound event to start its sound. I can place a few prefab instances and build my map with the preset only entities, because this is just dynamic entities, so I don't have to rebuild everything. And once we're in game, we can kick them around, shoot at them, and we have finished. I hope you enjoyed this tutorial and learned things along the way. So that's it, have fun and see you around.